Greetings, mathematicians. Today we're looking at determining the vertex and intercepts of a quadratic function. We are going to be focusing on the vertex formula, and we're going to use this one right here. Negative b divided by 2a gives us the value of x at the vertex, and f of negative b over 2a is going to give us the y value at the vertex. So let's take a look at that. First of all, I do want you to write the word vertex over here, because the vertex is always going to be in parentheses x comma y, either as a minimum or as a maximum. So what I also want you to write is the word vertex one more time, but this time it's going to be negative b divided by 2a, comma, f of negative b divided by 2a, because it's basically the same thing over here. So that's fine. First of all, we need to make sure our quadratic is in standard form, ax squared plus bx plus c. It is. So that means for this problem, our a value is 1, our b value is negative 2, and our c value is positive 5. So we just need the negative 2 and the 1 to find the vertex of this quadratic equation. So let's see, that's going to be negative parentheses for negative b divided by 2 parentheses. So that's going to give us a b value of negative 2 and a value of 1. This gives us negative 2 is really just 2. 2 times 1 is 2. This simplifies to 1 over 1. So our x value at the vertex is 1. So one more time, vertex. This time it's 1 comma. And now we take this value of 1 and substitute it into the equation. So I'm going to write the equation. Instead of x parentheses with a 1 for the x value, square it, minus 2 parentheses, 1 for the x value, plus 5. 1 squared is 1, minus 2 times 1 is minus 2, plus 5. 1 minus 2 is negative 1, negative 1 plus 5 is 4. So the y value at the vertex is 4. Now, that takes care of the vertex. X and y intercepts. Between the two, the y-intercept is going to be the easiest. The y-intercept is the value of y when x is 0. So, in order to find that, substitute 0 for x. 0 squared, 0. Minus 2 times 0 is 0 minus 0, still 0. 0 plus 5, 5. Always the easiest one to find. For the x-intercepts, that's going to be a little bit more challenging. Here, let's actually graph these 2 points and see if we're even going to have x-intercepts, because sometimes we don't. So I'm going to graph these 2 points, y-axis, x-axis, and I'm going to go ahead and go 5 in each direction. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So my vertex is at 1, comma 4. That's right here from the origin, 1 to the right, 4 up, and 0, comma 5. And so this point right here, this is either going to be the highest point of the parabola, if it was going to go a negative parabola, or it could be my lowest point, if it's going to be a positive parabola. So that y-intercept is pretty much going to help me determine that. 0, comma 5 is right over here. So I know that this has to be, and it is, it's a positive x squared, so it's a positive parabola. It's going to make a regular u. Negative parabolas make the upside down u. So in any case, you should also be able to tell that this is not going to cross the x-axis. So there's actually not going to be any x-intercepts, but there are imaginary solutions to this. And we do that, we find those solutions finding the, using the quadratic formula with a, b, and c values from standard form here. Now, the one thing I also want to mention is that the vertex is always going to be the axis of symmetry for both sides of the parabola, which means you're going to have mirror image points be the same distance from the axis of symmetry. So for example, if 0, comma 5 is 1 unit away from the axis of symmetry, that means I'm going to have 1.1 unit away to the right. That's going to be when x is 2, and we can easily substitute that in. 2 squared, that's 4. Minus 2 times 2, that's 4. 4 minus 4 is 0, and 0 plus 5 is 5. So 2, comma 5, which would be that mirror image point right there. So that is pretty much how I am going to sketch this quadratic parabola. I do want to find the solutions to the imaginary solutions. They're not real because it's not going to have x-intercepts. So I'm going to go ahead and put x equals negative parentheses b value of negative 2 plus or minus the square root of parentheses negative 2 squared minus 4, let me extend that radical sign out, times the a value of 1 times the c value of 5, all of that divided by 2 times the a value of 1. So let's clean that up as we go. Negative negative 2 is really just 2, plus or minus the square root of negative 2 squared is 4, minus the product of 4 times 1 times 5, which is subtracting minus 20. All of that gets divided by 2. So what I really have is x equals 2 plus or minus the square root of negative 16. 4 minus 20 is negative 16. There's my imaginary solutions. Because when you have a square root of a negative number, you're going to have imaginary part of the answer, it's a complex number, divide by 2. This square root of negative 16 is going to be equal to 4i. So let's actually put that right over here. Square root of negative 16 is equal to I times the square root of 16, so it's I times 4. We don't say that, we say 4i. So that part I'm going to simplify over here. So x is equal to 2 plus or minus, I'm going to go ahead and put the 4i, all of that divided by 2. That is the correct answer for the imaginary roots, for the imaginary solutions. However, I'm going to split this up, and 2 divided by 2 will simplify, 4 divided by 2 will simplify. I'm going to show that each part here. So this is with the plus sign, 2 divided by 2 plus sign, 4i divided by 2, and over here, 2 divided by 2 minus sign, 4i divided by 2. So what we really have, this is 1 over 1, 2 over 1, same thing, 1 over 1, 2 over 1. We really have 1 plus 2i and 1 minus 2i. And those are our two imaginary solutions.